drawing the path to rays. Okay. Reflected ray negative phase. The least thickness that will result in no light. So no light here means that is the destructive interference. Let's draw the diagram first. Incident light here go to the magnesium fluoride, will reflect it here. This is higher refractive index, right? Let's write the refractive index. Incident rectangle glass. Okay, this is 1.6 and this is 1.38. This is 1 for the refractive index. Okay, therefore it will be reflected here and out, and then reflected even more here, right? Because it's higher refractive index, reflected up, and then parallel to this thing, parallel, okay, parallels, and then incident angle. This angle here will be equal to this angle. This angle here equal to this angle. Yes, parallel. These two rays must be parallel, okay, and then parallel with this one. It will be reverted the phase. You add pi for the phase here. The phase will be changed by 180 degree. Okay, here, and also change this 1 pi. So it changed 2 times.
So 2 pi.
2 times for the first ray here and the second ray here. They are all both inverted in phase. Okay, both inverted in phase. Last time we had 2 cases. Let me open that thin film here. 2 cases called 1 phase change or 2 phase changes. Okay, and this case is 2 phase changes. So 2 phase changes. What is the equation for destructive interference? It's just the same as the double slit. Okay, meaning the path difference. Do you remember the equation?
2dn equals to m lambda.
Exactly. Very good. Thin film. It's not given in the booklet. 2 times of the thickness D of the magnesium fluoride coating layer. Okay, and times only 2D. And then you need to times the refractive index n, which is 1.38. Destructive interference means 2n plus 1 times the wavelength. Okay, or in other words, the wavelength here is taken to be the wavelength in the magnesium fluoride, which is the normal wavelength divided by n if you don't put the n here. Okay. So you can put the n here and not the n here, or vice versa, remove the n here and put the n here. Okay.
Is it m plus 1 over 2 lambda?
Lambda over 2, sorry. Lambda over 2, right? Odd number of half wavelength for destructive interference. But the wavelength here is the wavelength in the medium magnesium fluoride. Therefore, we take the given wavelength in the air, 5 times 10 to the 7, divided by the refractive index of magnesium fluoride. Okay. The minimum thickness D is when the n here is 0. So that will be the wavelength divided by 2 times of the refractive index, and 2 times here also. So that's 1/4. Okay, 5 times 10 to negative 7 divided by 4 times of 1.38. 5 divided by 4 times 1.38. 0.9 to significant figure 0.91. Okay, times 10 to negative 7. That is so small. Can we make that extremely thin layer of coating? So thin, right?
Yeah.